No, we didn't start with the derivative of e to the x. What was the first function we took the derivative of? X squared. That was definitely the first function we took the derivative of. If I asked you to take the derivative of this, what is the derivative of x squared? 2x, and the chain rule tells us we also have to multiply by the inner function. What is the inner function in this case? Just x. What is the derivative of x? 1. There's always been this invisible 1 that pops out on the outside because of the chain rule. The chain rule is always in effect. The chain rule is always in effect. The chain rule is always in effect. But when we started out, the chain rule was kicking out a 1, and we were just not writing out 1 when we did that. The chain rule is always in effect when we're differentiating. So we're going to talk about implicit differentiation, which is something that helps us differentiate implicit functions. Up until this point, we've been dealing with explicit functions. These are both explicit functions. Anybody know why these are both explicit functions? What do they have in common structurally? What do they have in common structurally? They're both what? What do they have in common structurally? Y, let me get this better here. Y is isolated. Therefore, it is defined explicitly. If you can isolate y, you have written the function as an explicit function. What happens if y was also on the other side? Would that be explicit? No, y is isolated. How many y's do you see? 1, and it's all alone on one side. If you have it in that form, it is explicit. Here's the thing. Are you always going to be able to isolate y? Are you always going to be able to isolate it easily? No, sometimes it's going to be super, super hard, and sometimes it's just going to be flat out impossible. So we need to learn a way to differentiate explicit functions. What does an explicit function look like? So for example, this one right here. This is an implicit function. Why is it an implicit function? Well, it's not an explicit function. Why is it not explicit? Yeah, Noah.
Because y isn't isolated.
Y isn't isolated. You see y right there? It doesn't tell you explicitly what y is. It doesn't say y equals anything right there. It has y as a part of it. Now here's the thing. Could we isolate y? We could. It's not impossible on that one. So let's do that one right here for a sec. Let's say we said x squared plus y squared is equal to 4. What do we do to both sides first? What's the great first thing to do? Yeah, Dave.
Square root.
Not yet, because if we do that, that doesn't do anything first because of the plus sign. What do you have to do first? If you square root, you can't square root each individual thing. You have to square root both sides. So what do you do first? Yeah.
Minus the x squared.
Yeah, so you get y squared is equal to what? 4 minus what? Now we take the what? We take the square root of both sides. So we get the square root of 4 minus x squared. This is not complete though. What did I not write in there that I need to write in when I take the plus or minus? I need a plus or minus because this right here is not a function. What shape is that? You should remember what shape that is. You remember what shape that is? Do you know what that's a graph of when you graph that? X squared plus y squared is equal to 4. Not a close, not an ellipse. Close. It is an ellipse, but a very specific kind of ellipse. What? It's a what? What are those in the back of the room? Some of those are what? Yes, that's a circle, everybody. The equation of a circle. You have definitely seen that before. You can prove that, not prove it, but you could graph this. When you look at this, when x is 0 on this, when x is 0, what's y?
4, no, 2.
2 or?
Negative.
Yeah, so y is 2 or negative 2, and then if y is 0, what's x?
2 or negative.
Exactly. So what does this look like? It's a circle of radius, what?
2.
Around the, with a center at the what?
0.
At the origin, 0, 0. Exactly. So here's the thing. Is that a function?
Yeah.
Nope.
No.
It doesn't pass the what?
Well,
Vertical line test. Are there vertical lines that pass through more than one point?
yeah.
So if you're going to define this, you need at least 2 functions. What are those 2 functions? You need the upper half and you need the what? Lower half. So you have 2 functions here. What are they? You have y is equal to the square root of 4 minus x squared. That's the upper half. And then you have y is equal to negative the square root of 4 minus x squared, which is the what? Lower half. So is it possible to isolate y on this one? Yeah, sure. Now look at these 2 functions. Let's just look at these 2 functions. We have our first function right here and our second function. If you wanted to, could you find the derivative of that first one? Do that for me right now. Find me the derivative of that first one. Find me the derivative of that. Write this to begin with. I wanted you to write it as y is equal to 4 minus x squared to the what power? So if you take the derivative of this, what do you get, Arvin? What do you get? Y prime is equal to what?
4 minus x.
Well, drop the 1/2 first. Drop the 1/2 to the front first. Do that for me. 1/2 what?
1/2 4 minus x squared
To the
negative 1/2
times what?
negative 2x.
Yeah, so you could stop there. Or can you simplify that a little bit? Yeah, what cancels? Those, the 2 and the negative 2?
Oh, yeah. True.
So what do you end up with? Y prime is equal to what? Negative x times 4 minus x squared to the what? What does negative 1/2 power mean? It's square root, but where? Yeah. So this is negative x over the square root of 4 minus x squared. So if you want to write it without the negative exponents, that's what it would be. Now, is the work for this one very similar? What's the only difference? What's the only difference between those two functions? Just the negative. So what can you do? If you know the derivative of the other one is that, what do you multiply that one by?
Negative.
So you end up with y prime for this one is equal to what? X over the square root of. But there's two derivatives because you need two functions. Now, can you get implicit functions that look crazier than that? Sure. What happens if I had a function that looked like, what happens if I had some path that looked like this? How many functions do you need to break that up into? Is that a function? No. Does it pass the vertical line test? No. So you need to break that up into a lot of different functions. Does this get really nasty really quick? Yeah, it does. So for example, what I mean is, this one, was it doable to isolate y? Sure. What happens if I gave you this?
Please don't.
What happens if I gave you that? Like y squared plus 3y cubed plus 2 equals 4x. Does that look like something you could isolate y in from? Not so much. But is that an implicit function? Yes. So is there a way to implicitly differentiate that? Yes, there is. Okay, so here's how you do it. Here's how you do it. Remember, when does the chain rule apply?
All the time.
All the time. Okay, so let's go back to this one. X squared plus y squared is equal to 4. That was our original function that we were talking about, right? What shape is that? What is that again? It's a circle. Now, do you agree that there is some function of y? Do you agree that you could isolate y in terms of x? We proved it, right? But do you agree that you can always do it? It's how hard changes, right? So do you agree that y is some function of x? Do you agree with that? Sure. So let's just substitute that in. What do we get? X squared plus f of x squared equals what? 4. Have we changed anything? No. We don't know what that f of x is, but does it exist? We actually do because we solved for it, but do all implicit functions have really nice solutions? No. Like remember this one I just showed you? Where is it? The cube one? No, that one's terrible, very hard. Okay, so if I wanted to take the derivative of this in terms of x, what's the derivative of x squared in terms of x? What's the derivative of that? Just 2x. And what's the invisible chain rule? Yeah, there's a 1 there. Do you agree that that's, are we okay with that? If I wanted to take the derivative of f of x squared, let's take the derivative. What do you get? 2 times what? What does the chain rule tell us we need to do? Do we change the inner? 2 times f of x to the what power? To the first. But then what do we need to, that's a first power. I won't put that in, that's a first power. What do we need to multiply by because of the chain rule? F prime of what? X. And this is the most common place people mess this up. What's the derivative of 4? 0. The derivative of a constant is 0. I can't tell you.
Would be 2, right?
I know. I can't tell you how many times people carefully do the hard stuff on the left. They leave the 4 in, and what happens to all the math afterwards? Everything's off. Are you okay with what I did right there? You okay with that? Okay. So, could we divide everything by 2 if we wanted to? Yeah, if we divide everything by 2, what happens? That goes away. What's 0 over 2?
0.
So what do we end up with? X plus what? F of x times what? F prime of x equals what? 0. What did we say up here? What was our original substitution? What does y equal? F of x. So what does y equal? Say it again. So what does this equal right here? What is f of x? So what do we have now? X plus y. What is f prime of x? Y prime equals what? 0. You with me so far? What can I subtract from both sides? X. Y prime is equal to, y prime times what? I forgot it, sorry. Y times y prime is equal to negative x. And what does y prime equal? Negative x over what? Over y. Now this right here is the implicit differentiation of the original function. Is that a simpler function than what we came up with before? What did we have? What was in the other derivative? Some square roots, right? Theoretically, are they the same thing? Oh, there's something different here. Is there an x and a y in our answer? Yeah, you're allowed to have that now, and you need that because look, on a circle, everybody, if I said x equals 1, how many points on the circle have x equal to 1?
2.
So instead of just needing x, you need the x value and the y value. You need the x value and the... You with me so far? You with me so far? Okay, so for example, let's just check something here, okay? If x is 1 right here, and that's not to scale, everybody. If x is 1, let's just check something. What's that point right there? If x is 1, what's y?
2.
1 squared plus what squared is 4 squared? 1 squared plus what squared is... 1 squared plus y squared is equal to 4. What does y equal?
2.
Nope.
It's only 3, so it equals 3.
So y squared is equal to 3. So what does y equal? What is he?
1 or 3.
Huh? Kids, I don't know. Is it just because it's early? Okay, so y squared is equal to 3. So what does y equal? Root 3. Plus or minus root 3. So what point is that? 1 root 3. And what point is this? 1 comma negative root 3, right? So let's say you wanted the derivative right here. Let's say you wanted the slope of that line right there. Do you want the upper function's derivative or the lower function's derivative? You want the upper function's derivative, right? Which one's the upper one? The upper one was this one right here, correct?
Yeah.
Agreed? What was the x value there? What was the point? It was 1 comma root 3, right? So what's the x value? 1. So you plug that in and what do you get? What is y prime when x is equal to 1? What do you get? Negative 1 over what?
Square root of 3.
The square root of 3. Do you agree? Should it be negative? Is that slope negative on this line right here?
Yes.
It's going down. Let's go back to our other derivative that we just did right here. That's pretty simple, right? What was the point we just took the derivative at? 1 comma what?
Root 3.
Root 3. Plug both of those in. What do you get? Y prime at 1 comma root 3. What do you get? Negative 1 over root 3. Do you get the same exact thing? How many functions? You just need one of those. You just need one of those. The key thing to realize is the chain rule is always in effect. The chain rule is always in effect. The chain rule is always in effect. Now, sometimes, can you isolate y? Sure. Do you see all that nasty algebra we had to do? Which one was easier, that algebra or this algebra? The second algebra, right. Sometimes you have to do it. Remember how I said you can get some things that are super, super, super hard to isolate? If I asked you to isolate y, is that something you know how to do? To be perfectly honest with you, I would have a very hard time off the top of my head isolating y because that's a cubic. Cubics are really nasty to deal with unless they're very specific. You factor cubics with like grouping and stuff, but if you don't have grouping set up, it's really hard. So again, do you remember what the first step was for implicit differentiation? What did I substitute? What was the substitution I made? Do you remember? I said y was equal to what? F of x. Y is some function of f of x. So what did I do with that? I then, what's that S word? I substituted. So what do I get here? F of x what? Minus x times f of x equals. Take the derivative of that in terms of x and tell me what you get. Take the derivative of that in terms of x and going to be. What do you?
3f of x squared.
3f of x squared, correct? Times what?
Times f of x.
Times f prime of x because of the what rule? Because of the
Chain rule.
chain rule. So that is correct, absolutely. So then you have to subtract something here. And it's going to, everything, all of this is going to equal what? What's on the other side?
-6.
Nope.
0.
0. What is the derivative of -6? 0. Be really careful about that. It's super important. So this is the second place people have to be very careful. Right here, what rule do you have to use? You have to use the product rule here. You have to use the product rule. This is super careful. You have to use product right here. So what's the derivative of the first?
1.
Times the second plus the first times what?
F prime of x.
Exactly. Exactly. So if our goal is to find f prime of x, what are we trying to isolate right now? F prime of x. Now, let's isolate f prime. So what could we do first? I would see that negative sign. Do you see how I put brackets around the whole thing? Is that really important? Super important because you're subtracting the derivative of the whole thing, not just the first term. So I would literally write 3 f of x squared f prime of x minus f of x minus x f prime of x equals 0. So if I want to isolate f prime of x, what do I need to move first? There's one thing I want to move. What do I want to move? There's 3 terms there. What term do I want to move to the other side? The what?
The one f of x.
Yeah, the one that's alone, right?
Yeah.
So you have this minus x f prime of x equals what? F of x. Now be very careful. What do I do now? I want to isolate f prime of x. What do I do now? No dividing. Nope. No dividing. What do I want to do? I want to isolate f prime of x.
Minus 3.
Nope. No minusing. Not multiplication, not division, not subtraction. I want to factor. What do I factor out, David?
F of x.
Close. We want to isolate. What do we want to isolate? You could highlight it to see it here. What's in both of them? F prime. So what do I pull out? F prime. So what's now? I have one of them, right? So what do I have left? 3 times f of x squared minus what?
X.
Equals. Now what do I divide both sides by? Nope. We want to isolate f prime of x. We're trying to keep it alone. What do we divide it by? We want to get, let's divide by that. So what do we have now? F prime of x is equal to what? F of x over what? 3f of x squared minus what? But what does y equal? We know that y is equal to f of x, right? Correct? So what can we substitute in now? What does this equal? Y over what?
3y squared.
So we just found y prime is equal to y over 3y squared minus x. This right here is just another way of writing dy dx. Remember how there's lots of different ways to write y prime? We just found it. Did we have to isolate y? No. We did not have to isolate y. We did not have to isolate y. We did not have to isolate y. So this looks like it's a lot of work. Do you know what it looks like if you try to isolate y? No. If you ever want to see what it looks like, look up the cubic equation. You know how there's a quadratic equation? Guess what? There's a cubic equation and a quartic. There's no quintic. That's another story. But do they get really, really, really complicated? Like the quartic, the 4th degree one, is like a page long. Like the formula is like a page. It's terrible. It's terrible. The fourth degree one, the quartic one is huge. There's 6. There's 1, 2, 3, 4, 6, 7, 8. What's really interesting, there is no 5th. This is super interesting, at least I think so. It's not that people haven't found it. They've proven it doesn't exist. There is no 5th degree solution. There's no one formula for it. Look it up. It's really cool. It's really, really cool. You can take college. There's some college math classes that talk about it. It's really cool. But theoretically, you're like, why doesn't it? Like ax to the 5th plus bx to the 4th plus cx cubed plus d. Like, why can't you use a, b, c, d, e and find it? You can't. Basically, what they've proven is that those 5 terms don't give you enough information to find one root. It's really cool. Okay, everybody stand up and stretch for a minute. Stand up. Variable, see, you see how it says t? Do you see any t's in here? You see any t's? No, I don't see any t's. So x is going to be x of t, and what does y going to be? Y of t. And now what do? Same process. What was that s word? What do we do? So we have negative 3 times what? X of t cubed minus 2 times y of t squared is equal to 5. Let's take the derivative now in terms of t. Let's do the first. Who wants to do the first one for me? Natalie, do the first one for me. What do I do first? What do I drop to the front? So what does it become? Negative 9 times what? To the times what?
X prime.
Yes. You want to just finish it for me? Minus.
4.
Yep.
Y prime.
Not y prime. You don't change it yet. To the.
1.
Yep. Times what?
Y prime.
Equals what?
0.
Yes. Right there, you have 2 things. You have dx dt and you have dy dt. Now this looks like it's terrible and that you don't really have one thing to isolate. You're going to get problems where they're going to give you x prime of t and they're going to give you y prime of t and y of t. And you have to solve for one of them. At this point, you'll get to plug things in. This right here, it says, what does it say for the question? It says find d dt.